EX. So I'm just letting you know, I think I made a mention of this, but clearly it hasn't sunk in. Banchan, are you keeping up with your work? Okay, guys, it is smart, especially kids aiming for a 5. Memorize the E negative X series. So EX is okay, but E negative X is smarter. E negative X, let me speak slowly. E negative X is actually the EX series with all the odd terms negative. So watch. So EX is 1 minus X over 1 factorial. Continue. Plus over 2 factorial minus X cubed over 3 factorial plus dot 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 negative 1 to the power of n X to the power of n over n factorial. It is smart to memorize the E negative X series. It appears so frequently. So rather than replacing every X with negative X cube or something, now can I just replace every X with X cube? Okay. So show the work. So it just becomes, look down now, 1 minus X cubed over 1 factorial plus over 2 factorial minus over 3 factorial plus dot 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 negative 1 to the power of n x to the power of 3n over n factorial.
This is the negative.
Yeah, sorry, that is E negative x. Yeah, E negative. Thank you. That was just a typo. Thank you. That's the E negative x series. So negative x cubed is that. So we can accelerate. Look at me. So there's like 2 steps simplifying. We already have the series. Okay, now read the instructions. So what do I need to do next step? Integral for f of x. Okay. So f of x equals integral 0 to x e to the power of negative t cubed, same thing, negative x cubed dx. Remember, t is just a dummy variable. So what is your first term going to be? Minus second term? Over 4, 1 factorial times 4, plus x6 over 2 factorial times, x7 over 2 factorial times minus x10 over times plus dot 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 negative 1 to the power of n x to the power of 3n plus 1 over times 3n plus 1. Okay. Now part B says, copy on part B. It just says, use the first 2 terms to estimate f of 1/2. So what do we just do? So I'm just going to plug in half. So it's just f of 1/2. So is that 1/2 minus 1/16 over 4, which is 1 over 64? And that's it, right? Oh, why am I stopping? I'm just following instructions, guys. I'm just following instructions. Simplify, tell me what you get. Go on. Was it 31 over 64? Okay. We're doing a review of the weekend homework. Have a look at C, please. Have a look at C. It says, explain why the maximum error. I think there was a typo. Make it 1 over 10 cube. I believe it was 1 over 10 cube. Why is the maximum error in approximating f of 1/2 in B less than 1 over 1000, 1 over 1000, or 1 over 10 cube? Often the AP will write in terms of powers. So what concept are we using? Maximum error. Okay. So part C, this is a maximum error. Who remembers the notation? F of 1/2 minus, hint, we use 2 terms in part B. F sub 2 of 1/2. Guys, this is a subscript. Look at me. For those of you a little confused on the homework in terms of notation, that just means we're using 2 terms in F. Only 2 terms. Will be less or equal to, which guy do I focus on? Okay, like a moron, I erase the board. Can you look down and see what is the third term? What is the third term? x7 over 2 factorial times 7. And what was the value of x they gave us? So should we plug it in? So less or equal to 1/2 to the power of 7. I'm writing like this, okay, like that. Times 1 over 2 factorial, which is 2 times 7. Now 2 to the power of 7, as everybody knows, is 128. So is that 256? Times 2. I'm doing the math in my head. That's 2 to the power of 8, which is 256. As all of you know that. Now, look at the board. Isn't 250 times 4 1,000? I'm speaking, so look at the board. I'm showing you the math. You don't have to do any crazy math. Isn't 250 times 4 1,000? So is it obvious 250 times 7 will be way over a 1,000? In case you're saying, where is this 1,000 coming from? No, first of all, I said make that 1,000. 10 to the power of 3. So is it obvious that that guy will be less than 1 over 1,000 then? I don't have to do much math. So please understand this. 1,000 is bigger than that. Will the reciprocal, this be smaller than that? I hope you understand the algebra. That's it. Oh, we're not done. I love Marzuk. She says, but it says explain. So who remembers the 3 conditions we should write? Or what should we check for? It is a alternating series. Look at it. Wasn't the f of 1/2 series clearly alternating? So we know since f of, no, or rather, was it the integral function? Correct? I'm looking up. Oh yeah, that guy, f of 1/2 function. F of 1/2 is alternating. Then what is the second condition? Thank you. Basically, the absolute value of terms, because we need to have only the function, which is the absolute value of terms. I hope you understand, we're applying only looking at the positive numbers, right? Absolute value of the terms is decreasing. For those of you who say, how do we know that? Look at the denominators. Everybody, look at your denominators. Are the denominators getting larger and larger? So the value should be smaller. And then finally, limit n approaching infinity of the terms, which is f of n. Okay, should be approaching 0. Exactly. So basically, the alternating series test. So I'm letting you know that carries 2 points, the work, and then 1 point for the explanation. It's a 3-point question. That's it. We were doing a review of Friday's lesson. Okay, oh my god, this had so many typos. And I did not have Marzuk to correct me. This was in class. Relax, I'll fix it though. So copy it on A, please. Okay, we discussed this on Friday. We discussed this on Thursday. I want to see if anybody other than Marzuk remembers how to do the problem. And let me tell you this clearly, the other class disappointed me. They had forgotten, except Soto, who's like insanely smart. And I go over this, I struggle through this every year. I can do 500 examples. Kids are just not paying attention to what is given, what is asked. Okay, so it says if f of x equals x cos x, write the first 4 terms and the n term of the series f dash of x. So first, if they say f of x equals x times cos x, what series should we obviously begin with? Cos x. Directly, what's the cos x series? 1 minus over 2 factorial plus over 4 factorial minus plus dot 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 negative 1 to the power of n. It's an alternating series. I need all odd powers. So what should my power be? 2n over 2n factorial. Can I just multiply the x? Which is x minus over 2 factorial plus over 4 factorial minus plus dot 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 negative 1 to the power of n x to the power of over 2n factorial. Before you finish, read the question. Have you answered the question? Thank you. Ms. Jung, who's reading the question, understands what's going on. That was just f of x. Please understand that. Yes. Yeah, the left-hand side was f of x. I do have it. Now I'm coming to the left-hand side. Now, Ms. Marzuk says, should we write f dash of x? Okay. So this is important. We're finding the derivative. Okay, what's the first term? Minus x squared over 2 factorial plus 5x4 over 4 factorial minus 7x6 over 6 factorial plus dot 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 negative 1 to the power of n 2n plus 1 x to the power of 2n, lower the power by 1, over 2n factorial. Okay. Now, copy down b. I'm writing the actual series on the board. Okay, that's not even close to being right. Just write down the instructions. Here's the actual series. 1 minus 3 pi squared over 2 factorial plus, copy down this series. Write down, use your result to find the value of. This is, it's not even close to being accurate. Okay, that's the value I need. The question says, use your result. Observe what we found. Compare. Okay, these guys, just compare. What is obvious? Is x pi. Again, you have to be alive. X is pi. But we're not done yet. We're not done yet. Nobody speaks. Now, this is the fourth time I'm asking the question. The question says, find the value of this guy. Somebody other than Marzu, tell me how to do it. It's staring at you. I can do 100 examples. You need to ask yourself, why am I not able to get the concept? Like, they are giving you this, they're giving us this. I just need to do this. So the question now says, find the value of that. Okay, Mr. Banchan. Yeah, how do we find the sum?
With the nth term.
It's not a geoseries. There's no. So it's all obviously I'm doing such a terrible job. I can do this kind of example like 500 times. Only Marzu is raising her hand. I need to find this. Ms. Running. No. That will give you f of pi. That's not pi. So you're telling me this is f of pi. How do you know this is f of pi? You just need to be alert. We found something. It's staring at you. Ms. Eunice? No, you are right. So, again, I don't know how to teach this concept. I can do 5 examples. If you don't study, it's staring at you. I need this guy. How do I find this guy? Ms. Romero. It's not a geoseries. Yes! We plug it into the f dash function. It's there. You just have to be alive. Like, I can do this 500 times. I don't know how to explain. Like, on Friday we did an integral. And the thing was, no, just plug into the integral. Can you see the left-hand side? You're focused too much on the right-hand side. All of you are focused too much on the right-hand side. But do you see the right-hand side equals the left-hand side? There's a reason we wrote the left-hand side, to help it, to make it easy for you. There's a reason I'm constantly saying, copy down the left-hand side, guys. Because if you don't write this, look at the board. Can you see now you're completely lost? But we are writing this over and over again. I keep emphasizing because you need to know this guy is the same as that guy. Add x equals pi. Can we find f dash of x? Find it yourselves. For those who say, I have no idea what you're talking about, look at me. That's f of x. Can you see? Find f dash of x. Plug in pi. Tell me the final answer. Do that yourselves. It's like you're focused too much on the right-hand side. You're not even aware what the left was. Tell me the absolute final answer. Negative 1. Is that amazing? All of that is actually equal to negative 1. If you understand that connection, this guy is the right hand side, which is equal to the left hand side. We can find f dash of x, plug in the pi, and we get to go. Alright? Okay, we're moving on. Copy down question number 3. Guys, I'll give you 30 seconds. Make notes to yourself about how to figure it out, because clearly we're having a lack of connection. This is the 4th time we're doing this problem, and some of you are still unable to make that connection. What notes would you write to yourselves? I'm asking you to think. In psychology they call it metacognition. You're thinking about thinking. Like, next time I see this problem, how will I think about it? I'm just unable to see those connections. So what will I write to myself? What is a letter you're writing to yourself to next time it triggers that? Okay, they give you a right hand side, focus on the left hand side and do the same operation. Okay. How do we do the problem? Yes. Oh my God, seriously? Nobody knew it in the other class. Marzu, I'm like super amazed at you. Super sweet little Marzu times 10 extra credit. There was nobody. She remembers everybody. Look at the board. Read the instructions again. This is what the kids who are not reading the instructions were doing. They said, should we use the LCD? That's not what the question says. Read the instructions. The question does not say determine convergence. Did you see that? It says find the sum. Feel free to write any notes you want to. There are only two series we can find the sum of. Repeat. There are only two series we know we can actually find the sum. For those of you saying, I have no idea what you're talking about. Please understand, for virtually all series, we only determine convergence. In other words, does the sum exist? How many of you understand what I'm trying to get across? Does the sum exist? Does it converge or diverge? Does the sum exist? Does the sum not exist? There are only two series we can actually find the sum. One is the telescoping series. It's called a telescoping. This guy is an example of a telescoping series. Who remembers the second guy? Geo series. An infinite geo series with a common ratio less than 1. Absolute value. That's the second series. So please understand the question was not saying check for convergence. So in the other class there were quite a few students apply LCT. But that's not the question. Okay, what I'm asking you for a trigger in a good way, for those of you, because you understand what trigger means. In a good way, trigger. How do you know it's a telescoping series? What in the question gives it away like it is a telescoping series? Sorry? No, the 2 on the top is irrelevant. The bottom is a factorable quadratic. We can use partial fractions. Make a note to yourselves. If the denominator is a part, and we can use partial fractions to write A and B. Okay, I'm going to give you 30 seconds. I'm going to pick it up from 2 minutes later. Find A and B yourselves. Do partial fractions. So it's A over, oh by the way, is the bottom n plus 3 or n plus 3 times n, whatever. So you're doing A over n plus B over n plus 3. So do partial fractions and figure out A and B. I'll pick it up 2 steps later. Okay, I'm going to make a guess. Is A 2/3? Is B negative 2/3? Okay, so I'm going to read out the series. So A was 2/3. Did we choose A to be n? N. Negative 2/3. Was that n plus 3? Now in the other class I showed them a trick. Look at the board please. I showed them a trick. I'm going to factor the 2/3. So in other words the problem becomes much easier. 2/3 summation 1 over n minus 1 over n plus 3. Okay, I'm jogging your memories. Who remembers what we did next step? Other than Marzu. Who remembers what we did next? I'm sharing this with you. Feel free to make any notes. This is day 103, 104. Telescoping series, we discussed it. Yes. We plug in test values. Thank you. We're going to plug in this. Okay, now I want to be clear on what I'm going to do. I'm going to find what is called Sn. Write this down. It is called the nth partial sum. I'm basically finding the sum of the first n terms. Nth partial sum. Again, I encourage you to study your notes from day like 103, 104. We discussed this concept then. And Mr. Bunjan correctly says plug in 1 to infinity, the first 4 or 5 values. Now, Ms. Marzu and I did this problem together. Marzu, because I have a good memory. The one we did was n squared plus 4n. Remember, it showed up way later. I made an easier problem. So look at me. The question then arises, Mr. Bunjan correctly says plug in 1, 2, 3. So the question says, Rama, how many terms should I plug in? I'm saying something profound. I hope you'll remember this. Plug in as many terms as possible till 2. Repeat. 2 of the terms cancel. But then you'll be able to see the pattern. Play along. I'm going to plug in 1. So what is the first term? 1 over 1 minus. What's your second term? 1 over 4. Plus. What will I plug in next?
2.
So 1 over 2 minus 1 over 5. Are any of the terms cancelling? Not yet. You'll continue plugging in till 2 of the terms cancel. Then the pattern appears. 1 over 3 minus Nothing cancels yet. Next term. Minus. Oh, is there any term cancelling now? The 4. You need to be alive. You need to be alive. Now, what is my rule again? You'll plug in till 2. Should we plug in the next one? 1 over 5 minus. Does another one cancel? The 5 guy. Plus dot dot dot. And plug in the nth term. 1 over n minus 1 over n plus 3. Okay, look at the 2 terms you cancel. Make a guess. So which are all the terms that'll start collapsing now? Thank you. Is basically any terms after 1/4, if you understand patterns. So will this term also collapse? Will that term collapse? Will that term collapse? So which are the only leftovers? So left side, Sn equals 2/3. Which are the only terms that will not collapse? 1 plus and 1 over n minus 1 over n plus 3. I don't have enough terms to collapse those. Okay. Now, for those of you who have forgotten the concept, 2, if anybody remembers what I do in the last step. Mazugu is raising her hand. Anybody else? For those of you who don't get it, I need S. Or more specifically, I need S infinity. I need the sum of infinite terms. I just found the sum of n terms. Who remembers what I do in the very last step? Mr. Banchan. Take the limit. Very good. So the concept is called S infinity is limit n approaching infinity, Sn. Take the limit, simplify, use LCMs, tell me the absolute final answer. Repeat, take the infinite limit for this expression, observe what happens, and then take LCMs for the remaining guys and tell me your absolute final answer. I hope you can add fractions. When you take the infinite limit, what do you observe happens? What cancels out? Because some kids are lost. Yeah, 1 over infinity is 0. 1 over infinity is 0. Those two will collapse. Take LCMs for the remaining guys, combine like terms, simplify, tell me your absolute final answer. Oh, Javidi is not here. Where is Javidi today? Okay, those of you finished, what is the absolute final answer? Louder? What did you get, Romero? 11 over 6? That sounds about right. Okay, absolute final answer, 11 over 6. Put this in a box, please. You need to know S infinity is limit n approaching infinity Sn. Yes, go on. Because I'm looking at patterns. 1/4 collapse, 1/5 collapse. There's nothing that pairs them up to collapse.
Wait.
Yes.
11/6 is just the value inside the bracket. Should we multiply it by 2/3?
Did they do it? So is it 11/3? 11/33? No, so what's the final answer? No, tell me the final answer. I'm just copying down whatever somebody calls out. We have a 2/3 outside. So what is the absolute final answer?
11 over 9.
1109. Thank you. Somebody confirm that. 1109. Thank you. Shh. Okay, we're moving on. Okay, copy down 4, please. Copy down 4. Quick. Now I'm letting you know, you need to be humble because this is stuff we did before the break. I do expect you to have forgotten. And hence the review. Yes. No, you're not reading the instructions. Using just follow the directions, using the integral test. So everybody, once again, you'll say, Rama, but why not P series, LCT P series? Can you please read the instructions? The AP is giving you clear instructions on how to do it. Okay, now get ready to see how challenging this was. This appeared last year, 2018. That is a 2018 question. So they gave you a partial fractions kind of guy, and they said use the integral test to do it. Okay, 4 over n squared minus n minus 2 from 3 to infinity. Who, if anybody, remembers the integral test? What do we just do? Next step. Just integrate it. So observe, this is equivalent to integral 3 to infinity 4 over n squared minus n minus 2 dn. I'm going to integrate that. Is that partial fractions also? Okay, find a and b. I'll pick it up 2 steps later. Go on, look down. Yes. My God. Okay, Marzu, you need to disappoint me sometimes. Yes, we'll do that afterwards. He says, Rama, it's an integral test. Should we check for conditions? Yes, we will go check for conditions later. And the question clearly said that. What conditions need to be met? Have they been met? Please observe how well prepared she comes to class. Okay, those of you way ahead. What is A and B? Anybody? I'm assuming, are you choosing the A guy to be n minus 2 and the other guy n plus 1? B to be n plus 1? I'm hoping, so we'll all be consistent. Those of you finished, what is A? 4/3? Okay, 4/3 n minus 2. The other guy was safely negative 4/3? Negative 4/3 n plus 1. I want to see if learning happened. If you understood the previous example, what should I do next step? If you understood the previous example, thank you, factor of the 4/3. 3 to infinity, 4 over n, just 1 over, right? 1 over n minus 2 plus 1 over n plus 1. Can we integrate? Integrate yourselves. First semester, basic integration. What's the integral of 1 over n minus 2? ln n minus 2 minus, that's a minus sign, right? Sorry, minus sign. Minus 4/3 ln n plus 1. Lower limit, upper limit. Okay, stop. Okay, now let me tell you why this problem was challenging. Now some of you will smartly say, no, I think we should need to do this. And you'll understand, like, man, Rama says things profound and he gives us tricks. If I do not follow what he does, I am going to make mistakes. Okay, now I'm going to describe the problem for you. Half the kids, this problem had a very low chance of success because kids did not have good algebra skills. Repeat, pre-calculus skills, which I have taught. And I have emphasized every single time, this is what you should really do. Okay, what's this? The answer is, look at me, I'm misleading you. Okay, refute me. Refute means tell me why I'm wrong. The answer is undefined. I plug in infinity, ln infinity does not exist. So diverges. But stop. If you look here, but LCD, PCD, isn't it clearly convergent? So you know we have a problem. So nobody speaks. How are we supposed to do that? What are we supposed to write always if you have good habits? Not you, you.
Condense it.
Condense it! If you did not condense, you got it wrong. That's a law property. Mr. Fernando smartly says, hey, we usually condense it. There's a reason why I emphasize certain things. Can I basically pull out the 4/3, by the way? So it's ln n minus 2 over n plus 1. 3 to infinity. Okay, let's see who has good skills. Now, this is just basic algebra skills. I'm going to plug in the infinity. Ask yourself, how do we always plug in infinity? If you were to plug in the infinity, what does it become? Very smart. Thank you, Ms. Noram, smart girl. She says 1. For those of you who say, I do not know how to plug in infinity. Guys, the infinity rule is highest power. Is the highest power n and n? That's the infinity concept. So that really is ln n over n, which is 1, minus, oh, by the way, what's ln 1? Okay, that's 0. Minus 4/3 ln numerator, denominator. That is your final answer. Stop. Therefore, summation an converges by integral test. We're not done. Since, okay, Ms. Mazu smartly said, wait a second, if you're doing the integral test, don't we check for conditions? So, who remembers the condition for the integral test? Let me make it easy for you. Everybody, look at me. Guys, the integral test, write this down. These are notes. The integral test has the same conditions as the alternating series test for the conditions. Integral test, same as AST reconditions. Now, here are the 3 conditions. All terms are positive. In other words, f of n or an are positive. Now, look at me. Look at me. We're not writing this. I'm just explaining. Now, you may say, but Rama, we never check for this, for ASA. Look at me. Actually, we do. Remember, when we have this, look at me. Don't we basically focus on that guy? How many of you understand what I'm trying to get at? Yeah, so all those terms are positive. Remember, we deal with absolute convergence. The AST says, okay, ignore that. That guy, nth limit should be 0. That guy should be decreasing and so on. So all those numbers are positive numbers, so we're okay. What's the second condition? Limit. This, guys, AST and both have the same conditions. N approaching infinity, AN or f of n should be 0. And what is the last condition? F of n or a of n should be decreasing. Okay, let's have a look. Just mental math. Isn't n squared or whatever in the denominator? As n rises, look at me, 3, 4, 5. Is this getting larger and larger? So 4 is getting smaller and smaller. So very easy check. So let's just write down since. Okay, now I'm coming back. Those are notes. So since an or fn are decreasing, and then just f of n are positive, or just say greater than 0. And we did this earlier before the break. How do we check if it's decreasing? It was there on your homework also. F dash. Okay, stop. Let me show you a shortcut. Look at me. Look at me. Isn't that like 4 over monkey? Do you see that? We're applying chain rule. Isn't that 4 over monkey? So let me make it easy. What's the derivative of 1 over monkey? What's the derivative formula for 1 over monkey? Negative 1 over monkey square. So write this down. Let me just mark it. So negative 4 over monkey square, chain rule, times 2n minus 1. Is that obviously less than 0? These are all positive numbers. Please understand. These are all positive numbers. Multiply by negative number less than 0. So f of n is decreasing. So it is there on your weekend homework. It said clearly check the condition. So guys, I'm making this clear. Integral test, you can't just do integral and move on. Nah, there are conditions that need to be checked and demonstrated. I made this emphatically clear. If you choose not to do it, I'm letting you know Marzuk is doing it. If you choose not to check your solutions, you may never realize like, oh, I'm supposed to be doing something that I'm not doing. Ask me. Yeah, she's smart. And basically what Marzuk was saying, Marzuk says, should you not check before? Technically before, it doesn't matter. The AP is not going to mark you down if you check after. It's just that, okay, all those conditions are met, so converges. All right. Let's move on. Okay, I actually had a typo in this problem. Can you please make that n squared plus 4? Okay, copy the question, make that n squared plus 4. That is a more interesting problem. This was a stupid problem. Where's Composano? Oh, he's over there. So Composano, n squared plus 4 is a more interesting problem. Guys, otherwise, are we smartly using LCD PCDs? Yes? No, but they say use the integral test. So you're getting practice. Is everybody okay that, look at me, is everybody okay? I'm not going to check for conditions. Isn't it virtually identical? Will f dash be in the denominator, negative 1 over monkey squared, for exactly the same process, be in negative number. All these numbers are positive. Look at me. If I plug in 3, 4, 5 squared, they're all positive numbers, decreasing, yes, go on. Sorry? But it wasn't linear in the previous problem too. We're using chain rule, remember? These are applying chain rule. So we're okay. Okay, so let's write this down please. So 3 to infinity, 3 over 4n squared plus 1 is equivalent to integral. 3 to infinity. Oh, sorry, thank you. N squared plus 4. 3 over n squared plus 4 dn. Nobody speaks. Who, if anybody, recalls how to integrate that? Nobody speaks. Okay, go on, Romero.
Divided by 4.
Wait, oh, okay, you're on the right track. Eventually, where does it lead? No, I get that. But eventually, what expression or what formula? Tan. Inverse, thank you. Let's do a sidebar. See, the class has forgotten. So it's good I'm doing this review. Be a little humble, please. Any integration method is fair game. Integration by parts, use substitution, and so on. This is inverse trig integrals. So see, write on the formula, please. See if this comes back. 1 over 1 plus u squared du for u sub equals tan inverse u. We're reviewing that concept. and see if the concept comes back, then we usually write the formula so we can compare, right? So guys, if we compare, who remembers what we do next step? Okay. Yeah. He correctly says take out the 3. Okay, what else? Compare this guy and that guy. Should we rewrite? So I'm going to skip a step. Is that actually 4 plus m squared? And then, so I'm going to pull out the 3. And as Ms. Romero smartly said, can I pull out that 4? So if I pull out that 4, the expression really becomes 1 plus, who remembers? Over 4, dn. Now I'm going to do u sub. U equals, who remembers? I'm pointing. Who remembers what I choose u to be? N over 2, very good. Or half n. Therefore du equals 1 half dn or dn over 2. Introduce a 1 half. Balance with a 2 on the top. Stop. Now at this stage, Macharia smartly said, hey Rama, should you not change the limits? Yes. So if that's n over 2, the lower limit will change to 3 over 2. Very good. The upper limit is still infinity, correct? So that's 3 over 2. Integral 3 over 2. Is that just now 1 over 1 plus u squared? Du? 3 over 2 to infinity. Okay. Which is 3 halves integral. Oh no, I'm done. Is that tan inverse u? Lower limit? Upper limit? Okay, Mr. Park got 3 times the extra credit by answering the question tan inverse infinity. Calculate it yourselves. What's tan inverse infinity? I'll give you a hint because some of you have forgotten. Tan is y over x. So the ratio is y over x. Eventually, the ratio needs to become infinity. So what angle that works? Nobody speaks. Raise your hand when you figure it out. I'm offering 3. I don't know. I offered extra credit, but because it was Park and he's a sophomore who skipped, I offered him 3 times the amount of extra credit. See if you can figure out tan inverse infinity yourselves. Look down. Ask yourselves, I'm giving you the formula tip. Tan is y over x. So y over x, I'm giving you a hint, is undefined. So when will that happen? Okay, raise your hand so I don't call it out so you're ruining it for the others. Please don't make a guess because I want to quiz you like why and you'd better know how to do it. Anyone? Inverse tricky, you're in BC guys. AB, they want to ask these questions. In BC, it's fair game. Hint, tan is y over x. And y over x is undefined. So what should we do? I'm guiding him, practically giving it away. Yes. Pi over 2. And Ms. Romero gets twice the extra credit because she's a junior instead of being a sophomore. Okay, write this down. I'm not putting on a show. Do a sidebar. This is tan inverse infinity. Remember, that's y over x. See if this comes back. If it's y over x should be undefined, what should be true? X should be 0. Is it not x equal to 0 on the y-axis? That's positive infinity, so should we choose that guy? We choose that guy for negative infinity. So final answer, pi. This guy is pi over 2. Let's plug that in. So we have 3 over 2. I'm erasing the word. Equals 3 over 2 dot pi over 2 minus 3 over 2 tan inverse 3 over 2. That's okay. That can't be simplified. Leave it alone. That's your final answer. Oh, we have to write a conclusion. Therefore, the original guy, summation an converges. Oh, make a note. That exists. That's finite. Okay, that's obviously exists. Therefore, it converges by integral test. Now, to be clear, we should be checking for conditions, but I want to make it tedious. The same conditions apply. So remember, it's 3 conditions. They're all positive values. It's decreasing, and the infinite limit is 0. Yeah, memorize it, please. Memorize it. Okay, I'm teaching this year better than I've ever taught before. So we are actually going to do, I've never done these problems before. Not in the last 4 years I've taught this. We're actually going to do examples on DCT. Okay, relax. It's stupidly easy. Relax. Okay, copy down 6, please. It's our first exposure to direct comparison test. And we will actually work the problem. Okay, copy the question and put your pencils down. Okay, before I move on, I'm addressing the class. Please understand that the chapter test is on Thursday, Friday. Now, how many of you are in drama? Okay, as you guys realize, there's drama going on for kids in drama on Thursday, yeah? And then how many of you are in ASB? Okay, there's drama going on ASB on Friday. How many of you know what I'm talking about? Okay, there's stuff going on. Of course, I don't care. I don't care about those things. So the test is on Thursday, Friday. So you guys will make arrangements if you're affected in drama or ASB to come and take the test. That's on you. That's on you. To be clear, please understand. Now, yesterday when Ms. Marzuk and I were discussing the solutions, I asked her, Marzuk, be honest with me, how long did it take you? She says 45 minutes. I said, Marzuk, don't write 45 minutes. You'll freak out the kids. Like, how is it that she's taking only 45 minutes? I said, please write down 55 minutes. And that's why she wrote 55 minutes. I'm letting you know. She said, Rama, the test, this assignment was super easy. I just raced through it. So the point is this. The homework is really time for between 55 to 65 minutes. But since Marzuk has a firm understanding of every single concept, she's able to race through it. Here's another thing she emphasized. I've actually shared this with you. And I'm saying this, maybe one of you will be inspired to follow her model, which is this. She says, Rama, I've stopped looking at my phone or doing it on my computer. I take printouts every single day. I'm able to race through it without any interruptions, any distractions. So those of you who say, I do it late in the night, she does not do that. She does the homework at 4:30, 5:30, 6:30. At worst. For those of you not aware, she's tutoring today. On days she tutors, she sends me a text. Can you please send the homework early so I get a head start on the homework? That's how dedicated she is. So those of you say, man, my typical test score has been a C or a D. I'm telling you, you guys just do, like lose scenario. She does win. I'll do the homework early in the evening. I'll spend about 10 minutes looking over my notes. I'll do it when it's fresh in her mind. I will study before I do the homework. She has good habits. Let me be emphatic. Now, even though it'll embarrass her, she's not smarter than you. But she has different work habits. Her work habits are very different. And then the most important thing is she does not get distracted when she does her homework. There are no interruptions. So for those of you on social media or texting friends, you get a ping like, I need to respond. Or Instagram, you're making updates. No. Those are unsuccessful habits. So you need to ask yourself, this homework took me 1.5 hours. I'm telling you the AP time limit is 55 to 65 minutes. And as we go through the year, I'll be timing you. And you need to ask yourself, like, what is going on? Because I'm not even close to being successful. Now, this is literally what happened. She said, Rama, it took me about 45 minutes. I said, oh my God, you'll freak out the kids if you wrote 45 minutes. Please update it by 10 minutes and write 55 minutes it took you. That'll be reasonable for them. Look at her. Yes? Is that what the actual thing happened? It actually took her 45 minutes to do. So you need to ask yourself, why would it take her 45 minutes? It took me 2 hours. What's going on? It may be conceptual lack of concepts, but there's also work habits. Do the homework early. Spend about 10 minutes. Invest about 10 minutes studying your notes. So today's homework will be mimicked by this. So you need to say, okay, I'm going to study, not just do the homework directly. And I'll get away from social media. I'll get away from YouTube stupid videos. I'll get away from Instagram, WhatsApp, all that crap. Snapchat. Okay, now here's the direct comparison test. I'm doing some notes. Write this down, please. Write down DCT. So DCT says this. If you have 3 series, but here are the terms of every series. So AN less than BN less than CN. Let's discuss this very, very quickly. Actually, let's just do 2 of them. Okay, you know one, you know the other. If we are making 2 bullet points, I know that BN is a convergent series, converges. And this says AN is always below BN. Then summation AN, I'll give you 2 options, choose wisely. Converges or inconclusive. Converges, where smaller, the sum exists. So the smaller guy, the sum should also exist. Summation AN converges. On the other hand, I say summation AN diverges. Keep in mind, BN is bigger than AN. Therefore, BN... No. Pay attention. I said the smaller guy diverges. And we are bigger. Should we diverge? Bn diverges. I told you the smaller guy diverges, as in the sum does not exist. And finally, what you are confusing with this one, Ms. John, I say Bn diverges. Therefore, An, we could be much smaller and therefore converges, so summation An is inconclusive for that series. This is kind of intuitive. If I'm smaller than a convergent sequence, I must converge. If I'm bigger than a divergent sequence, I must diverge. But if I'm smaller than a divergent sequence, I don't know. It could converge or diverge. Okay, we're going to use that concept here. So, look at the problem, please. Put your pencils down so I can tell you how absurdly easy this is. Look at me. Have they given a series for us to use? So, in other words, they have given us a series to use. Look at me. What do we know about the convergence of the 1 over n sequence? Nobody speaks. Guys, this is not an alternating series. It's just 1 over n. 1 over n converges or diverges? Nobody speaks. Ms. Mendoza. It's the easiest series. Diverges? Why? You're correct, by the way. Why? What 0? Oh, no. You're saying 1 over infinity 0. You're using the n-term test. The n-term test does not work. N-term test is just the bouncer on the bar. It just lets you go. By what test that guy diverges? Mr. Dan. P series. N to the power of P. Okay, now stop. If that guy diverges and you have an understanding of the direct comparison test, I should make sure that guy will be bigger or smaller? This guy should be bigger than that guy, this guy should be smaller than that guy. Common sense. Bigger? Look at me, for those of you who don't get it. If I say I'm going to show this is smaller, isn't smaller actually inconclusive? How many of you understand the concept? So is my basic goal is to show this guy is bigger than that guy? Let me show you how to show that. So guys, look at me. So before you start the problem, I want you to think. So the series are summation 1 over n and summation 1 over ln. Okay, so what? Initially I remove these. So my goal is to show, remember, my goal is to show this guy is bigger than this. Is that clear? Now, students in the other class said, Rama, how can I prove that guy is bigger? Now, I do not know whether you will learn this principle in middle school. If I cross multiply, write down greater than. If I cross multiply, it should be true. Let's see. Is that true or false? ln is smaller than n. True or false? That's polynomial, that's log. True. Log is always smaller than polynomial. This is true. Therefore, this is true also. That's what we have to prove. Okay, we're almost done. So now can I take summation? I'm just making a series now. I hope you understand the logic. Initially, I start with an is smaller than bn. Can you see that? Then I go to the series. Now, guys, I'm going to write a one-sentence conclusion. Since summation 1 over n diverges by p series, parentheses, p equal to 1. Therefore, summation 1 over ln n diverges by... How easy was that? How easy was that? That's it. We're bigger than that guy. I know that's it. So you start by doing, okay, what do I know about that series? They're helping you, it says, with the aid of that, to figure out. Okay, let's do another question for practice. Copy that problem down. No, that's it. There's nothing else to be done. It's a very simple, elegant concept. Ms. Marzuk and Ms. Dong, you can take credit. He answered that question correctly. Relax, I'm asking him the next one too. So don't worry. I'm just kidding. Okay, let's go with this mentally. Guys, before you do the problem, you want to think about it. I'm speaking, so look at the board. What do we know about that series? Nobody speaks. Mr. Villafuerte. 1 over en. What do we know about that series? Converges or diverges and why? You're correct. Why? Because otherwise then you're just guessing. By what test? Obviously, it's literally 5 seconds. Ms. Riney. GOCs. Can you give it a hand, please? Exponent. GOCs. Oh, but stop. We proved that's convergent. According to the direct comparison net, we need to demonstrate that this guy is bigger or smaller? Smaller. If you're bigger, it's inconclusive, remember. Smaller. So let's prove that. So I'm going to show work. I'm going to start. Okay, what's this? So I have to show that 1 over En is bigger than 1 over n factorial, right? Or the other way around. It doesn't matter. You can prove that 1 over n factorial is smaller than 1 over En, correct? Now, what is the trick I showed you in the previous problem? I want to see if learning happened. Cross multiply. So the top left will become En. No, I'm writing it this way. And the top right will become n factorial. Is that not true? Exponential. Oh, is that elegant or what? So this is true, then that is true. Can you now put the summation symbols? Write a conclusion yourselves. Since summation 1 over En converges by GO series test, summation 1 over n factorial converges by, is that ridiculously easy? Now, as a bad teacher, I never taught my kids last year or the year before that how these are done. Yes?
In the conclusion, do you have to say that because it's less than 1?
No, this work is showing, is enough. There's no more work to be done. Okay, now, guys. These two series that we discussed are so powerful. Oh my God. Did we skip a problem? Oh, we skipped that. No, we did that problem. Oh, we did that. Okay. Okay, guys, draw a skull. These are famous series which we don't have regular tests for. So memorize this. Please, Raja, draw a skull. So we know that 1 over ln series diverges. You have to memorize it. I'm letting you know. And summation 1 over, was it n factorial? Converges. After you copy that, put your pencils down. I want to have a discussion on this. If I did not tell you DCT, look at me. If I did not tell you DCT, what test would you apply? For both of them. I'll give you a hint to make your thinking easier. It is the same test you'll apply to both of them. Which test would you apply? Louder? Nth term test is not a test for convergence, man. Ratio. Thank you, your factorials. Ratio test. Here's a problem. Look at me. Both of them by ratio test give a value of 1. For those of you who remember your notes, 1 is the inconclusive guy. So all I'm trying to tell you is none of the other tests work except the DCT. So I want you to memorize it. They occur very frequently. Memorize that. 1 over ln. Oh, and for those of you thinking integral, I'm going to say something profound. Do I not need another n term for the integration to work? Or maybe n on top, so I can do parts? There is no n term. In case you're saying, what are the integral test? It doesn't work. So we are forced to use a direct comparison test, hence my teaching you. Okay, let's move on. Oh, copy it on 8, please. My God, as usual, we're behind the other class. I don't know how or why. Mr. Kamazani, at this stage, we were in question number like 11 or 12 in your class. Look at the time. Oh, sorry. It says with the aid of 1 over n factorial. In the other class, Mr. Soto answered this question correctly. Okay, guys, we just learned that 1 over n factorial converges. So we just need to demonstrate that this guy is smaller. So this guy will converge too. So let's write them. So we have sine squared n. As a rule, I'll write the smaller guy to the left. Is that clear? So everybody understands? A smaller guy will write to the left. Over n factorial. Guys, initially I do not put summation. Initially I do not. I need to prove this. Okay, that's what I have to prove. Oh, Mr. Campuzano, it's almost like the more I teach, I learn myself. Can we use the cross multiplication trick? Let's cross multiply. So n factorial. Can I divide both sides by n factorial? Will they cancel? What will I get on the right hand side then? Why is that always true? Nobody speaks. Raise your hand when you figure it out. Why is that always true? Like I'm giving it away. At this stage, I'm giving it away. Why is that always true? The other class had to do more thinking. Come on, guys. What do you know about that function? Come on, guys. The sign always lies between -1 and +1. It's a decimal. And when you square it, will that be less than 1 then? Make a note. This is always true. It's the sign function. Lies between -1 and +1. Inclusive. Come on, guys. In the other class, they had to figure it out from scratch. I made it easy by this cross multiplication trick. Okay, so this is true, that is true. What do we do next step? Who remembers? I have this, what do I do? Put the summation symbol. Okay, write a conclusion yourselves, go on. Ooh. My God, we're like 4 problems behind. Okay, stay with me. Since summation 1 over n factorial converges, therefore summation sine squared n over n factorial converges by... Oh, by the way, in case you say, but what reason do I write for 1 over n factorial? Relax, that's a famous series. Okay, you don't need to. Okay, copy down 10 please. Okay, Mr. Arnold today in the other class was, I believe the American expression was on a roll. He answered so many crazy hard problems on his own like that. So, initially, what tests are we applying? Looking at how that question looks like. We should be obviously... No, initially. You're right, eventually. Initially, which one are you applying? Louder? Anyone? Yes? Oh, no. We're going beyond the nth term test because that factorial is in the bottom. Yes, go on. LCT. Should we apply the LCT? Leading terms. Applying the LCT. Okay, now afterwards, when we're doing the LCT, here's an interesting problem. Look at me. It's been a while since we did the LCT. It actually should work. For those of you who have forgotten, isn't it like AN and BN? So we're showing LCT. So make a note in case you've forgotten LCT, which is virtually all of you. N factorial plus 2. Okay, we're going to call that AN. See, that comes back. What's the leading term for this function? 2n over, should we call that guy Bn? Okay, now to demonstrate if Bn converges or diverges. Therefore, which test should I apply? Ratio test. We've never done a problem like that. We use a ratio test for Bn. So limit. N approaches infinity. Bn plus 1 over Bn. Mr. Kompazani, I think in the other class we mechanically wrote An plus 1 over An. Okay, equals limit. N approaches infinity. 2 to the power n plus 1 over n plus 1 times n factorial. I'm skipping a step. Times n factorial over 2n. Take the limit, please. Everybody, the weakest kids forget to write this. Then they get lost. Like, what am I doing? No, there's a limit. Take the limit. Tell me the absolute final answer. What do we get? It's not a trick question. What do we get the limit to be? Miss Baba? 0, thank you. Because isn't it 2 over n? Or 2 over n plus 1? Which is 0. Therefore, Bn, summation Bn, converges by ratio test, right? Summation Bn converges by ratio test. Okay? We're not done. Who remembers what is the other work we need to show for the LCT? Who remembers? Okay, by the way, this is day 104, 105, 106. You've forgotten. Here's the work for LCT. Write this down. Limit n approaching infinity. An over Bn is 1. Therefore, since summation Bn converges by ratio test, summation An converges by LCT. Is that clear? Okay, we'll do 2 more problems. I'm supposed to do this, but I'll do this tomorrow. Okay, in the larger scheme of things, this guy and this guy will be the last problem. Okay, copy down 11, please. This is like a 30-second problem, so you can accelerate. We'll do this mentally. For the most part. Okay, guys, come on in. But otherwise, you'll have to lower your volume. Otherwise, come on in. because I can always hear Jung Jr. from across the hall. I really let you in because of Jung Jr. because I can always hear her. Okay, hurry up, please. Hurry up. Get a chair at the back. Get a chair at the back. Okay, guys, stay with me. We'll just discuss this. Look at that series because it looks weird. Use common sense. Do not abandon your common sense. What might I do first step to make my job easier? Anyone? I can't hear you. Anyone, you can speculate. What do you mean by split? Separate them. Should we distribute the summation? Let's make 2 series. Okay, summation. 3n plus 1. Guys at the back, you'll have to keep quiet. Park. How do you say shut up in Korean? Yeah, say that to yourself. Say that to yourself. Summation. Does everybody understand the logic? Okay, so I'm just creating 2 series. Now mentally, we're not showing work. That's plus 1 here. We're not showing any work. That guy converges by Geo series, LCT. Everybody okay there? Converges by LCT. I'm just showing some work on the side. Is Bn basically 3 over 4 to the power of n? I hope you can follow the logic. Okay, and then Geo series. And mentally again, that guy converges by... guys, we're not using... It's foolish to use a telescoping series test. That's only if the question says find the sum. How many of you understand what I'm trying to say? We're just interested in convergence. But converges by LCT P series, right? LCT. Parentheses P series. So Bn is basically 2 over n, right? Therefore, that guy converges. Okay, therefore, that guy converges. So the theorem says if 2 series converge, then the sums and differences converge also. That exists, that sum exists, well, the total sum exists. Is that clear? Okay, last problem of the day. But we're not doing all of it. I want you to take down only this part. The rest of it is just blah blah. Okay, copy down this part. Okay, guys, this comes in multiple choice. This is it. I'm letting you know it's a tricky question. So it's the maximum error concept we discussed on Friday. Please study this example before you do your homework. Please, I'm begging you. It's trickier than it looks. Again, if you're not checking your solutions against Ms. Marzu, you will not know that it's completely incorrect. Ms. Isiodia, why are you here? How can I help you? Okay, you can take yours here. Come here. Ben. It's a key. For those of you who didn't get it, I said it is a key. Okay, stay with me, please. Stay with me. So this is the maximum error concept we learned on Friday. Is that clear? It says add x equals 3.8. We wish to approximate the series using the first 3 terms. You can sit down, Isiodia. Isiodia, you can sit down. No, you're blocking, silly. You're blocking, yeah.
Is that a typo? By how what?
Yeah, by how much? Thank you. It should say by how much would the estimate. Okay, by how much would the estimate? Can you remind me about sending this document?
Mm-hmm.
Can you send me?
I have to stop it early since I might die soon. I'm sorry.
All right. Everybody. Okay.